Hey guys, what we're going to be talking about today is about weathering. And we're not talking about the weather outside, like whether it's snowing or raining. We're talking about weathering as in weathering rock. And there's definitely a big difference between weathering and erosion. Oftentimes what we've been talking about in class is that, the erosion of the sediment on the stream tables. It moves those sediments away. But how do those sediments occur? How do they form? How do we get big rock into smaller rock? And it all comes down to weathering. Weathering is breaking. So when we weather a rock, we're breaking a rock into its smaller parts. And erosion then is talking about moving that rock or taking that rock away from its original place and moving it away. So weathering is breaking a rock. Erosion is moving or taking away of the rock or sediment. So as you guys know in class, we're talking about sandstone or sand. Which comes first? Is it the sand that comes first, or is it the sandstone that comes first? And so as we're looking at this investigation, hopefully you started to pick it up and you started to understand that really, if sandstone is made of sand, the sand has to come first. So how does that happen? How can we go ahead and get the sand to be that small so that it then can go ahead and form sandstone? Well, it comes down to weathering. So when we talk about weathering, there's two different types of weathering, breaking of the rock. There's a physical process, so physical weathering, and then there's chemical weathering. So there's two different ways. So when we talk about physical weathering, we're talking about breaking the rock into smaller pieces. And that's oftentimes called mechanical weathering. We're going to use the word physical weathering instead of mechanical weathering, just because a physical weathering might help you understand it's something that's physically done to the rock, that's not changing its actual identity. So I want you to think about this for a second. What's the difference between this and this? Taking a hammer and breaking rock and having two rocks collide together, that's really doing the same thing. It's what's called abrasion. So here we have an image of abrasion to kind of give you an understanding of what it is. Abrasion is just really when we have rocks colliding into one another. It could be caused by wind pushing sand against a rock that's kind of acting like sandblasting, or it could be water that's moving rocks and then the rocks are colliding. And that physical contact it's called abrasion. Well, there's another example, it's called frost wedging or ice wedging. And oftentimes water gets down into the rocks. Well, then when the temperature changes and ice forms, ice expands. And so when it expands, it's going ahead and causing the rock crack or fracture to get bigger and bigger, and then pretty soon the rock splits apart. So ice wedging or frost wedging is really when the ice is going ahead and forming, that's causing the rock to be pulled apart. Then we also have what's called root wedging or root pry, and that's just simply the roots of a plant go ahead and break the rock apart into smaller sections. And so I want to make sure we understand the physical weathering is just breaking the rock. It's not changing the rock in any way, shape, or form. So if we have limestone and then we have a whole bunch of sand or rock hitting that limestone and it breaks into smaller pieces, those smaller pieces are still limestone. That's what we're talking about when we're talking about physical weathering. Now you can see when you have the more physical weathering that occurs, the more hitting of the rock and everything else, you'll start to see that it changes its shape. Rocks, when they first break apart, they're going to have really sharp edges, and so we describe that as being angular. And then as they continue to go ahead and get weathered and pounded and hit, they're going ahead and those rough edges are starting to get smoothed out. And so we're going to be using words like angular and rounded to help describe our smaller rock particles, so like sand and so forth, because that really does help us understand some things. If you see a piece of sand or rock that's really, really sharp edges, you know that it hasn't had a lot of weathering, so it's probably pretty close to its original source of where it came from. Now, chemical weathering, I want to make sure we start to understand that this is something a little different than physical weathering. It's when we're actually taking a chemical and changing the rock so that it's something different. So a mineral in the rock changes into a new substance. So it's no longer the same kind of rock. So here we have sinkholes and caves, a picture of sinkholes and caves. And I want to make sure we understand the reason why those form is all due to chemical weathering. So those awesome landforms where you see those big stalactites and stalagmites in a cave, those are all formed from chemical weathering. When you see these big, massive, you hear stories on the news about big, massive sinkholes that are forming. It all has to do with chemical weathering of the limestone. I want to make sure we understand how chemical weathering can occur. One way that it can occur is when the gases that are in the air, oftentimes from pollution, we could have different sulfur dioxide gases from a chemical plant. We could have lots of carbon dioxide gases from exhaust. But those gases are oftentimes carried up into the air. And when they combine with water vapor, they go ahead and they start to form into an acid rain. And notice there's this statue here. You can see that over time, the face of the statue has completely disappeared. And it all has to do with acid rain chemically weathering the rock. We started seeing a lot of major damage to many of the statues that we've had for long periods of time. They've all of a sudden started to go ahead and weather and erode, and it all has to do with this acid rain. So another example of chemical weathering that's actually natural in form, that means that we're not going ahead and doing anything, we're not going in and creating this, it actually happens in nature, has to do with the chemical weathering from plants. In the roots of plants, oftentimes in the sediment or in the dirt, they're letting out carbon dioxide. And when that carbon dioxide kind of combines with water that's in the ground, it forms carbonic acid. Is when this carbonic acid starts to chemically weather our limestone and causes these big, huge, massive holes in our ground. Lichens also do the same thing. You probably see it on rocks. You might even see it on trees. But this is an actual living organism. And this organism, biological nature, it goes ahead and releases some carbon dioxide. And again, it does the same thing. When that carbon dioxide combines with water, it starts to create a carbonic acid. Physical weathering versus chemical weathering. And how weathering is different than erosion. We oftentimes use the word eroded, and what we really need to make sure we're understanding is, are we talking about that rock being taken away, or are we really talking about the breaking down the rock into smaller parts, which is weathering? If you have any questions, make sure you go ahead and ask me in class, and we'll talk to you tomorrow. See you later.